You have probably never thought twice about who made the battery in your car. You plugged in, you charged, you drove. That felt like enough. And for a long time, it was. Think about the last time you stopped at a fast charger. The cable goes in. The percentage climbs. You are standing in a parking lot, maybe getting coffee, maybe just watching the number tick up, and the whole thing feels seamless. Routine, like it just works because someone, somewhere figured it out. That feeling is not an accident. It is the product of an industrial system so large, so deeply embedded, and so quietly efficient that it becomes invisible the moment it functions. And invisible systems are the ones nobody questions. Here is what you were not thinking about while that charger ticked upward. Somewhere between 200 and 300 separate companies contributed a piece to the car you were standing next to. A factory in Wrocław made part of the wiring, a plant in Nagoya made the cells, a lab in Munich wrote part of the firmware. You never see any of them. You see the badge on the hood. But here's the thing you were almost certainly wrong about, and this is the part that should stop you cold. You probably assumed that the car maker whose badge is on that hood controls the technology inside it, that Ford decides what Ford's battery does, that Volkswagen sets the ceiling on Volkswagen software, that the company with the name controls the capability. They do not. They never did. And in 2026, the distance between the automakers who finally understood that and the ones still operating as if it were not true has become something close to irreversible. This is not a story about Tesla being better. It is a story about a trap, one that was hidden inside the most efficient industrial system ever built, and about what happens when one company decides to build a door in the wall while everyone else is still admiring the architecture. Stay with this one, because by the end, the car you drive, or the one you want to drive, will look completely different to you. Before we get into what Tesla is doing differently, we need to establish something that almost no car content explains properly, and that is how cars actually get built. Most people think Fords build Fords, Toyotas build Toyotas, Teslas build Teslas. In reality, every major automaker assembles cars. The building, the actual manufacturing of the components that go inside, is done by a massive, invisible global network of suppliers. There's a hierarchy to this world. At the top are what the industry calls Tier 1 suppliers. These are the companies that deliver finished systems directly to the automaker's assembly line. Your airbag system? Probably Autoliv. Your infotainment hardware? Likely Harman or Continental. Your braking system? Bosch or ZF. Your wiring harness, the nervous system of the entire car that can contain up to 3 miles of copper wire? Almost certainly Aptiv, Lear, or Yazaki. Below them are Tier 2 and Tier 3 suppliers, the companies making the components that go into the components. A single modern car contains somewhere between 200 and 300 different companies before a single bolt is turned at the final assembly plant. This system evolved over decades because it was efficient. Automakers could focus on design and final assembly. Suppliers could specialize. Everyone got predictable volumes. Everyone made money. But this system has a critical vulnerability that nobody seriously examined until Tesla came along. When every automaker uses the same Tier 1 suppliers, every automaker's products converge toward the same cost floor. If Bosch supplies the brakes to Ford, GM, and Volkswagen, none of them can have a braking system cheaper or more advanced than what Bosch decides to sell them. The technology ceiling is set by the supplier. The cost floor is set by the supplier. The automaker's engineers are essentially integrators, putting together components they didn't design and couldn't build cheaper on their own. Tesla looked at this system and made a decision that seemed insane in 2012 and looks like pure strategic genius in 2026. They decided to become their own supplier wherever it mattered most. And if you want to understand exactly where that decision is about to break the competition in half, ask yourself this. When was the last time you heard a Ford engineer explain what chip is making the driving decisions in their most advanced vehicle? Because Tesla's engineers can answer that question in their sleep. They designed it. They own it. They're already building the next one. Nothing illustrates Tesla's supplier strategy better than batteries, because batteries are not just a component in an EV. They are the EV. The battery pack is typically 30 to 40% of the total cost of an electric vehicle. Whoever controls the battery controls the economics of the car. When Tesla launched the original Roadster and then the Model S, they sourced their cells from Panasonic, specifically cylindrical cells originally designed for consumer electronics. It was a pragmatic decision. Panasonic had the volume, Tesla needed to move fast. Over time, that relationship deepened into a genuine partnership. Panasonic and Tesla co-invested in Gigafactory Nevada, the largest battery factory in North America by floor space. On paper, this looked like a tight, mutually beneficial alliance. But Tesla was already planning its exit, or more accurately, its independence. In parallel, Tesla began sourcing cells from CATL, the Chinese battery giant that is now the largest battery manufacturer in the world. CATL supplies not just Tesla, but also BMW, Volkswagen, Ford, and dozens of other automakers globally. For Tesla, this relationship served a specific purpose: volume flexibility and pricing leverage. Here is where it gets strategically interesting. By having both Panasonic and CATL as suppliers, Tesla could play them against each other on price. Anytime CATL's pricing became uncomfortable, Tesla could reference its Panasonic relationship. Anytime Panasonic got complacent, CATL was there. This is supplier leverage that most automakers lack because they are too committed to a single battery partner to credibly threaten switching. But the deeper move, the one that makes everything else irrelevant, is the 4680 cell. Starting around 2020, Tesla began developing an entirely new battery cell format in-house. The 4680, named for its dimensions, 46 millimeters wide and 80 millimeters tall, is not just a bigger cylinder, it is a fundamentally different approach to battery architecture. Tesla's 4680 uses a tabless design that reduces internal resistance, which means lower heat, faster charging, and more usable power. It also uses a dry electrode manufacturing process, developed partly through Tesla's acquisition of Maxwell Technologies, that eliminates the solvent-based coating process used by virtually every other battery manufacturer on Earth. That solvent process requires enormous, expensive drying ovens that consume massive amounts of energy. Tesla's dry process eliminates them. The result? A cell that costs less to manufacture, performs better, and integrates structurally into the car's floor, the structural battery pack concept, eliminating hundreds of pounds of additional support structure. CATL cannot offer this to Ford. Panasonic cannot offer this to Toyota, because Tesla designed it, Tesla owns it, and Tesla is the only customer. This is what supplier independence looks like when it actually works. You don't just escape the cost floor set by your supplier, you set a new cost floor that your competitors cannot access at all. Think about what that actually means. Every dollar Ford spends negotiating battery pricing with CATL is a dollar spent trying to reach a ceiling that Tesla has already demolished. The competition is not happening on the same floor. It is not even happening in the same building. If the battery story is about escaping dependence on a critical material supplier, the chip story is about escaping dependence on something even more fundamental, the brain of the car. For most of automotive history, the computers inside cars were mundane: engine control units, transmission controllers, basic safety modules. The semiconductor content of a car was a small fraction of its total cost, and automakers were happy to source it from established suppliers like Infineon, NXP, or Renesas. Then, Tesla started building cars around a fundamentally different premise, that the car's software and the hardware running that software was the product, not the chassis, not the interior, the intelligence. The first serious signal came in 2016 when Tesla announced that all cars being produced were equipped with the hardware for full self-driving capability. The chip running that system at the time was from Mobileye, an Intel subsidiary that was also supplying driver assistance technology to BMW, GM, Nissan, and many others. Tesla broke up with Mobileye in 2016 after reportedly disagreeing over the pace of development and critically over data access. Mobileye wanted to retain control of the camera data generated by Tesla's fleet. Tesla said no. That decision, choosing data ownership over a convenient supplier relationship, is one of the most consequential engineering decisions in automotive history, and almost nobody gave it the attention it deserved at the time. Tesla spent the next 3 years designing its own AI chip from scratch. In 2019, they unveiled what they called the full self-driving computer, featuring a custom neural processing chip designed entirely in-house by Tesla's silicon team. Elon Musk stood on stage and made a direct claim. This chip outperforms every competitor's hardware on the specific task of neural network inference for autonomous driving. It was a bold claim. Independent benchmarks largely supported it. The reason a custom chip beats a general-purpose chip is architectural specialization. Nvidia's data center GPUs are extraordinarily powerful general computing tools, but they consume enormous amounts of power and generate enormous amounts of heat relative to what is actually needed for real-time driving inference. Tesla's custom chip does one thing: processes camera feeds through neural networks fast enough to make driving decisions in milliseconds, and does it with extraordinary efficiency. Now consider what this means for the competition. Ford's Mach-E uses a chip from one supplier. GM's LITHIUM platform uses chips from another. Volkswagen is building partnerships with Qualcomm and others. Every one of these automakers is dependent on a third party to define the ceiling of their autonomous driving capability. Tesla's ceiling is defined only by how good their own engineers are. And here's the question worth sitting with for a moment, because this is the one that doesn't get asked enough. If you were a Volkswagen executive and you understood all of this clearly, what would you actually do? You cannot buy your way into a decade of institutional silicon design expertise. You cannot hire your way to parity in a single budget cycle. The capability gap is not a number on a spreadsheet. It is a structural reality built over 10 years of compounding decisions. And the next generation chip, reportedly called HW5 or AI5, targeted for the second half of 2026, is by some estimates 10 to 50 times more powerful than the hardware currently installed in Tesla vehicles, the same hardware that already leads every competitor. For Ford to match that chip, they would need to either convince a supplier to custom develop it exclusively for them, an enormous investment that no supplier will make for one customer, or build their own silicon design team, which takes years and requires talent that does not grow on trees. Tesla has had this silicon team for a decade. They are not waiting for anyone. Let's talk about something that sounds profoundly boring, but is one of the most telling examples of how supplier dependency traps legacy automakers: the wiring harness. Every modern car contains somewhere between 1 and 3 miles of copper wire. This wire connects every sensor, every actuator, every light, every motor, every computer. It is one of the most labor-intensive components in the entire vehicle, which is why virtually every major automaker has their wiring harness assembled in low-wage countries, primarily Mexico, Morocco, and parts of Eastern Europe. The companies making these harnesses, Aptiv, Lear Corporation, Yazaki, Sumitomo Electric, employ hundreds of thousands of workers globally. It is a massive, entrenched industrial ecosystem built around a fundamental electrical architecture, 12-volt systems that have been standard in automobiles since the 1950s. The reason cars use 12-volt systems is historical inertia. When the electrical demands of a car were modest, headlights, a radio, basic sensors, 12 volts was perfectly adequate. But as cars added more and more electronic systems, the 12-volt architecture became increasingly inefficient. More current means thicker wires, more heat, more weight, more complexity. The industry has known for decades that 48-volt architecture would be better. It allows 4 times the power to be transmitted through the same wire diameter, or conversely, the same power through wire 1/4 as thick. Thinner wire means less copper, less weight, lower cost, simpler assembly. But switching from 12-volt to 48-volt across an entire vehicle lineup requires redesigning every single electrical component in the car, every control module, every actuator, every connector. The investment is enormous, and because every Tier 1 supplier has their entire product catalog designed around 12-volt systems, they have actively resisted the transition. The chicken and egg problem is real. Automakers won't switch until suppliers support it, and suppliers won't retool until automakers commit. Tesla, characteristically, decided to just do it themselves. The Cybercab is designed from the ground up on a 48-volt low-voltage architecture. The refreshed Model Y, Project Juniper, is expected to adopt it as well. Tesla designs its own control modules, its own actuators, its own connectors. It is not waiting for Aptiv or Yazaki to catch up. The result? Some estimates suggest Tesla can cut the total length of wiring in a vehicle by more than 90% compared to a traditional architecture. Less wire means less weight, which improves efficiency and range. Less complexity means faster assembly and fewer failure points. And lower material cost compounds directly into margin. The legacy automakers understand this perfectly. Volkswagen has been talking publicly about 48-volt architecture for years. So is Mercedes. So is GM. The technical case is not in dispute. The problem is the supply chain they are locked into. You cannot redesign 3 miles of copper wire across 300 component suppliers in a single model year. The transition, if it happens at all for legacy automakers, will take the better part of a decade. Tesla doesn't have that problem because Tesla doesn't depend on those suppliers for the components that matter. By now, a pattern should be emerging, and it is worth naming it directly because it is the actual mechanism behind Tesla's structural advantage. Every time Tesla identified a component where supplier dependency was limiting their performance, cost, or competitive differentiation, they vertically integrated. They brought it in-house. They designed it themselves. Battery cells, AI chips, vehicle software, charging infrastructure, now electrical architecture and wiring systems, and with Optimus, eventually the human equivalent labor on the factory floor itself. This is not just a technology strategy. It is a business model strategy, and it creates a compounding effect that is almost impossible to reverse engineer from the outside. Here is why. When Tesla designs a chip in-house, they gain something beyond just a better chip. They gain the ability to co-design the chip and the software simultaneously. The hardware team and the software team are in the same building, working on the same timeline. Features that would require a supplier negotiation, a product roadmap approval, and an 18-month design cycle at any other company can be iterated on in weeks at Tesla. When Tesla designs their own battery cells, they gain the ability to redesign the car's structural architecture around those specific cells, as they did with the structural battery pack in the Model Y and Cybercab. No supplier-sourced cell comes with the freedom to embed it structurally into the vehicle floor. Suppliers sell components. They do not sell you the right to restructure your entire vehicle around their component. When Tesla builds their own charging network, they gain behavioral data about their customers that no other automaker has access to. They know exactly when people charge, where they charge, how far they drive before charging, how charging behavior correlates with range anxiety and purchasing decisions. This data shapes product decisions in ways that are invisible from the outside, but deeply influential on the inside. The trap for legacy automakers is that this is not a problem they can solve by hiring more engineers or spending more money. Vertical integration is not a sprint. It is a structural transformation of what kind of company you are. Ford is a car assembler that has spent 100 years optimizing the art of coordinating suppliers. Becoming a battery company, a chip company, a software company, and a robotics company simultaneously while still selling cars competitively is not a strategic pivot. It is a complete identity change, and large organizations do not change identity quickly. Volkswagen's attempt to build its own software division, called CATL, has been publicly documented as a painful, expensive struggle. Years behind schedule, billions over budget. The problem was not money or talent. The problem was that a company built to manage suppliers is not naturally good at building vertically integrated technology. The muscles are different. The incentive structures are different. The culture is different. Tesla was born vertical. Every other major automaker was born horizontal, and in 2026, the distance between those two starting points is becoming a canyon. Now let's talk about the companies in the middle of all this, because their position in 2026 is genuinely fascinating, and almost nobody is analyzing it. Take CATL, the world's largest battery manufacturer, supplies Tesla. Yes, but it also supplies BMW, Volkswagen, Ford, Stellantis, and dozens of other automakers globally. CATL is, in one sense, the most important company in the EV transition that most consumers have never heard of. Here is CATL's problem. As Tesla scales its own 4680 production, Tesla's dependency on CATL decreases. Within this decade, Tesla's internal production may supply the majority of its own battery needs. That means CATL loses its largest, most technically demanding customer, the one that pushed CATL's engineers hardest and generated the most prestige. Meanwhile, CATL's other automotive customers, the legacy automakers, are losing EV market share to Tesla and to Chinese domestic brands, several of whom also buy from CATL, but increasingly are developing their own battery technology as well. CATL is watching its customer base erode from both directions simultaneously. Now consider Bosch, the largest automotive supplier in the world by revenue. Bosch supplies braking systems, steering systems, fuel injection, sensors, and dozens of other components to virtually every automaker on Earth. As Tesla eliminates traditional hydraulic systems in favor of brake-by-wire and steer-by-wire, electronically controlled systems that require a fundamentally different supplier relationship, Bosch faces shrinking content per vehicle from Tesla specifically. Bosch is not standing still. They are investing heavily in EV and software-defined vehicle components. But the transition is expensive, the timeline is long, and in the meantime, they are managing a portfolio heavily weighted toward internal combustion engine components that will eventually be worthless. The suppliers who built the horizontal model, who built their business on selling the same component to 20 different automakers, are facing a future where their best customer is eliminating them component by component, and their other customers are losing the market share that justified the production volumes that kept prices low. This is the invisible earthquake underneath the car industry in 2026. Not just Tesla versus Ford, but the entire supply chain ecosystem slowly being reorganized around a company that is trying to need it as little as possible. So the next time someone asks you why Tesla is so hard to compete with, why Ford can't just copy the Model Y, why Volkswagen can't just hire the engineers, why the gap keeps widening instead of narrowing, you can give them the real answer. It is not the cars. It is not even the technology. It is the invisible architecture underneath the cars. The suppliers who are slowly losing their grip on the components that used to make every automaker equal. The chips being designed in California that nobody else can buy. The battery cells being built in a format nobody else can use. The wiring being cut to a fraction of what the rest of the industry thought was possible. Tesla is not winning because they made a better car. They are winning because they are systematically eliminating every layer of the industry that used to make all cars equally limited. And by 2026, those layers are almost gone. The people who watch Dravexa come here because they want the version of this story that doesn't get told in press releases or earnings calls, the structure underneath the headlines. If that's why you're here, subscribe, because this map is just getting started.